In looking at periodic trends, I'm hoping that a lot of this is familiar to you from last year. We're not going to spend a lot of time on some of this early periodic table, history of the periodic table. I would know and be familiar with Dmitri Mendeleev, the father of the periodic table, was the first one to really start organizing the elements based on groups that had similar properties. He focused mainly on organizing the elements by atomic mass, which is okay. I mean, in general, as I look at periodic trends, the elements do increase in atomic mass, but they don't increase in a set increment. It could be from one element to the next, I increase by 1 AMU, the next one increases by 20 AMUs. So he did leave spaces in his periodic table if he noticed a large gap in atomic masses. He could maybe speculate that there could be an element that's not discovered yet. I'm not exactly sure what that element is. It's probably going to have similar properties to the elements nearby. But again, it's hard to predict, exactly what mass are we looking for, because the atomic masses don't increase in steady increments. Henry Moseley focused more on atomic number. Atomic numbers do increase by 1. So if I noticed a gap on the periodic table, we have element number 108, we have element number 110. We know, or we can speculate, that there's probably an element 109 that just hasn't been discovered yet. Or maybe it hasn't been discovered in a stable state yet. So if you look at different periodic tables, like there's an old one, or 2 old ones on the walls in the classroom. There are holes in some of these periodic tables even today to represent the fact that there may be undiscovered elements that we're still working on. Another section of this study guide that we're really not going to spend a lot of time on together in this video are things like properties of metals, nonmetals, metalloids. I'm hoping that's something that's familiar to you. I mean, even the freshmen in biophys and physical science look at properties of metals versus nonmetals. I'm also not going to spend a ton of time looking at the groups on the periodic table, because I know this is something that you've done in the past. And if you haven't looked at specific properties of different groups, you can look at your textbook. In general, I would know that alkali metals are soft, highly reactive metals. This is group 1, like lithium, sodium, potassium, rubidium. And we'll look at some of these metals in class. So, I'll show you lithium and sodium and potassium so that you can see they're soft metals. They are metallic, and they're shiny, and they do conduct electricity. They're highly reactive because they only have that 1 valence electron, and it's easy to lose that 1 valence electron and become a stable +1 ion. Now, in general, as I go across from like group 1 to group 2 and then into the transition metals, we typically see elements become a little bit less reactive. Now, the alkaline earth metals are still reactive metals. They only need to lose 2 electrons in their stable ions. That's easy to do. But it's still easier to lose 1 electron rather than 2. These are still soft metals, but they are a little bit harder than the alkali metals. And again, we'll play with some of these guys in the lab, in class. Transition metals are where you find all your typical metals, your copper and iron and zinc. So these are going to be very stable metals. They're not as reactive as group 1 and 2. These are the D block elements. So again, trying to figure out their charge can be a little bit tricky or unpredictable, which is why in a formula you'll see a Roman numeral used with transition metals. As we move into the P block, or what's sometimes called the main block, you get some pretty stable groups of elements, the boron, carbon, nitrogen, oxygen families. Now when you hit the halogens, you've got the most reactive nonmetals. These guys only need to gain 1 electron and become stable -1 ions. So again, when we think about bonding, which we'll hit up in the next chapter, the halogens love to bond with group 1 elements It's like a match made in heaven. Group 1 elements would like to lose an electron. Group 17 would like to gain an electron. So you've got the most reactive metals bonding with the most reactive nonmetals to form very stable compounds. Finally, you hit the noble gases, which we all know are non-reactive because they have full orbitals. They do not need to gain or lose or share electrons, so they really do not need to form ions. And finally, we kind of touched upon the F block at the bottom of the periodic table. This could also be known as the rare earth metals. You can kind of think of them as part of the transition group, but they're pulled aside because they do have some special properties. A lot of them are synthetic, a lot are radioactive. So these guys also fill the F orbitals, which we just mentioned, which is why they're kind of set aside as their own little group on the periodic table. So again, this would be a section that you might want to look at in your textbook if any of this is unfamiliar to you. But if I'm referring to the halogens or if I'm referring to the alkaline earth metals, you should be familiar with those groups on the periodic table and some of their general properties.